Hi everyone, I'm Chris Crone. I work in engineering at Docker. I'm part of the application definition team. We're mostly in Europe. I'm based in Paris, and we've got a couple of people in Cambridge and some more in Paris. We're responsible for Compose, Docker app, Compose in Kubernetes, among other things. So today we're going to take a look at what problems CNAB tries to solve, the CNAB specification itself, because it's pretty new and not many people know about it. We'll take a quick look at the CNAB ecosystem, and then we'll ask, what's next for CNAB, because it is quite young. So to start with, we'll talk about the why of CNAB. So why did we build this thing? Before we can do that, though, we need to talk about what an application is, because CNAB stands for Cloud Native Application Bundle. We need to know what we're talking about. So the Oxford English Dictionary defines an application as so. So a program or piece of software designed to fulfill a particular purpose. That's a pretty loose definition, if you ask me. I feel like they didn't really try. So we can maybe do better. We're a bunch of people in tech. We can maybe answer that question a bit more concretely. So is an application a binary in a virtual machine? Is it a binary in a container? Is it multiple containers orchestrated by Kubernetes? Is it a hosted database and some lambdas? Or is it any combination of the above? So it turns out if you ask 10 people, you'll probably get 10 different answers, because applications are very specific to organizations and to people. So you write an application to solve a problem, which means that it might even be something completely different. So that hasn't really got us to anywhere better, but we can ask the question, how do you deploy an application? So once again, it completely depends. If it's a binary, I hope you're using some sort of package manager, so like apt. Maybe you're putting up some infrastructure, so you can use Terraform. If you're installing something to a Kubernetes cluster, you could be using Helm charts and Helm. Or if you wrote your own kubeyaml, maybe you're just using kubectl apply. Compose also works on Kubernetes, so you could use Docker Stack Deploy. Or maybe you have some specific infrastructure thing that's only provided by AWS, in which case you need to use their CLI tooling. So that's how we got here. That's a good thing, not a bad thing. The reason that the CNCF landscape is as big as it is because there are lots of different problems to solve, and you need lots of different tools to solve them. The problem is that each tool comes with its own version management, and each tool probably comes with its own package manager. So you have this nightmarish landscape where you can't deploy an application easily because you need multiple tools. So what is CNAB? Well, it stands for Cloud Native Application Bundle. Yep, another acronym. It's a packaging format for distributed applications. And it's a specification. So the primary audience of CNAB is people making tools. So what are CNAB's goals? Well, it's to solve that problem we saw. It's how do you deploy a complex application easily? It aims to be cloud agnostic, so you shouldn't care where you're running it or how you're running it. It aims to be secure, because we live in a world now where we can't have nice things. And it aims to handle a spread of use cases. So it's everything from IoT to edge, air-gapped, normal clusters, everything. So right about now, there's probably a bunch of alarm bells going off. Why do we need yet another standard or yet another spec? Oops, sorry. To make this happen? The alarm bells are good, but I'd like to reassure you that we're not creating CNAB alone. So we're doing this with a bunch of other folks who are actually in the room here today as well. From Microsoft, Pivotal, Bitnami, HashiCorp, CodeFresh. We're doing this in the open. So we have bi-weekly meetings. And the idea of doing this way is that we want to get a bunch of different use cases and test them as we're building the spec. So we build something that actually resembles the real world. And obviously, in order for it to be cloud agnostic, we need a bunch of different people working on it. So how do you go about putting together a specification that tackles something this complicated? Well, you need to start by finding what's common between applications. So every application has a definition. This could be your Helm chart, it could be a Compose file, it could be kubeyaml. It's the description of what will be inside the application. You then need tooling to deploy and manage your application. So in the Helm case, you need the Helm CLI and tiller until V3 comes out. You need Docker Stack deploy or the Docker CLI to deploy compose files. You need kubectl to manage kubeyaml and so on. And finally, you have these parameters and credentials. These are things that you want to set when you deploy the application. Parameters are things like ports. So an operator will say, I want this to expose something on this port. And credentials will be things that you use to call APIs to deploy your application. So it could be a kube config, a set of certificates, or something else. The other thing that we thought about when we started putting the spec together is what do we have already and what can we reuse? We're not the first people to work in this space. We should try to reuse what we have. So I talked about having a definition. There's a notion of an artifact where we could build this into an immutable thing that we can then hopefully share. So we have something for this in the container world. So in the container world, we have a Docker file or something else to define what the container image will look like. We have an OCI image that you build that into, which is an immutable artifact that can be signed so that you can secure it. And we have OCI registries, which you can use to share these OCI images. So for applications, maybe we can do the same thing. The definition part's going to be difficult because, as I showed you before, each of those different tools will have its own method of defining a definition. So maybe that part's not that easy. But maybe we can package these as OCI images, and maybe we can store them in OCI registries so that we can share them and not have to rebuild the infrastructure from scratch. So let's take a quick look at the CNAB specification itself. It's broken up into a bunch of pieces. We're working on different pieces in parallel because, as you saw before, there's a bunch of us working on this. The first three, so the bundle definition, invocation image, and runtime, are part of the core specification, and these are nearly stable. We're hoping to stabilize them pretty soon. There's then the claim store, signing, and distribution portions, which are works in progress. So we'll start with the bundle definition. This includes the common parts of the application that we saw before. So we have the metadata, so things like name, version, description. We have a reference to the invocation image, which I'll get to just now, but that's essentially the installer. We have a list of parameters, a list of credentials, and a list of executable images. So on disk, it's JSON. And so you'll see on the first line at the top there, we have the metadata. So this is things like a name, version, description. We then have a list of images. These are invocation images, so these are the installer images. You can use Docker images or something else. We come from a container background, so that's what we use. We then have the credentials. So you'll see here we have something named kubeconfig, which will be mounted to a path that you can specify. And we have parameters, which are strongly typed, so you can validate them, which is great. So you can, for example, for a port, you can set an integer, you can set a default value, you can set minimum, maximum, and so on. For strings, you can use regex and whatnot. It's really cool. And there's some other things that you can store inside the bundle.json. The next thing we have is the invocation image. So the invocation image, as I said before, is the application installer. It's generally a container image, but it doesn't have to be. It contains the application definition, so let's say your kubeyaml, and the deployment tooling, which would be your kubectl, for example. It has a specific file system layout and a well-defined entry point with required actions. So we'll dive into that, don't worry. So just taking a look at what the file hierarchy looks like, you have something like this, where you have some definition, which is highlighted here. So in this case, I've got a database which we could deploy with Terraform, because it's a hosted database, and then some kubeyaml that we'll just kubectl apply. You then have this run executable, which is what you need to make the entry point of the installer image, which can either have the tooling built inside, or it could just be a shell script that does something else. OK, so now we have these two parts already. We have the bundle.json, or the bundle definition, and the invocation image. We then get to the runtime, which ties all these things together. So the CNAB runtime reads the bundle.json, or the bundle definition. It then executes the image with the CNAB action, injecting the parameters, waits for the invocation container to complete, and then stores the result as what we call a claim. So that gets us to the claim store. This keeps track of installations so that you can, you basically have a store of what's been installed. And each installation has a unique name so that you can record the actions on each installation. So you could say what the last action was, what the status was, which bundle was used, and which parameters were set. This is primarily to make subsequent actions easier because it means you don't need to re-specify which bundle you used, which parameters they were, and so on. And so I think that's about high time for a demo. In this first demo, I'm going to be showing you how to write a CNAB from scratch, just to show you how easy this is. All right. All of the demos are on GitHub, so you can check them out later if you'd like. I don't guarantee they'll work on your machines, though. But so here we have my demo directory. I've got a makefile just to make things easier for me. Oh, you can't see, sorry. Which screen do I need to put that on? Let's see if that, no, all right, hold on. Right, there we go. I'm probably going to actually mirror my display or else I won't be able to see anything. There we go. Okay. Oop. There we go. Is that big enough for the people at the back? Good. All right. I hate demos when you can't read what's being said. I'll make it bigger anyway. All right. So here's what I have inside my directory. I have a makefile, which just makes my life easier so I don't botch the commands. I have bundle.json. I have a tool named duffle, and I have an invocation image folder. So let's start with the bundle.json. So this is pretty much the simplest CNAB you can write. You'll see that the schema version is the working draft of v1. I've named my application bundle. It has a description, so that's, if somebody finds it, they can do something with it. I have a version. I then have a list of invocation images, which I'll show you how I built just now. And I can add maintainers and other metadata as well. So if we look inside the invocation image directory, we'll see that I have a Docker file, and then I have a run tool with a main.go. So that's all. Invocation image. What I'm going to show you first is the Docker file. So this will show you how the invocation image is built. So I'm using a multi-stage build. It's very simple. The first step builds a Go program, which is my main.go, and the second step just copies the results of that and sets the entry points to /cnab/app/run, which is the standard CNAB entry point. And I'll show you now the Go program. Oh. So in the first block of consts, I have the keys for the environment variables. So as I said, the runtime tool injects the action, the installation, or the bundle name and the installation name as environment variables, along with some other things. So I've got consts just to keep track of that. I then have the 3 required actions, which are install, upgrade, uninstall. That, for any application, it maps pretty well. And then I just have some simple error checking before I have this switch over here, which switches on the action. And so what it's going to do is when I install, it's going to say hello, and when I uninstall, it's going to say goodbye. That's it. So what I can do now is I can make my invocation image, which will just copy my command. So I'll show you. This is just a simple Docker build. I'm tagging it for to push it to a repo that I have. As I said, I've already prepared this demo to make sure it will work without the network, so that's not a very interesting part. Then to install it, what I will do is I will get the install command. So I'm using duffle here. Duffle is the reference implementation for CNAB. It's something we've been developing along with the spec to exercise the spec. In this case, I'm telling duffle to install. I'm giving it a name for my application, so the claim that we'll store it as. I'm passing it the bundle.json because it's going to read that to find out which invocation image to use. And I'm telling it that the bundle.json is a file and that it's insecure because it's not signed. Otherwise, it'll error out. So we'll see now it's executing the install action. And we see hello KubeCon because it's gone through that, it's run the image and gone through that Go program. In the same way, if I wanted to uninstall now, instead of having to re-specify the bundle, I can just uninstall it by name. So there you go. And that'll say goodbye KubeCon. So that's the simplest possible hello world example of CNAB. Right. So let's take a look at the ecosystem, because I talked a little bit about duffle. So the first tool is Duffle, which is hosted on the Deus Labs GitHub repo. It's the reference implementation, and it's a CLI tool. So we use this primarily to exercise the specification, and it's vended in a bunch of the tools that use the CNAB spec. We then have duffle-bag, which is a GUI tool for manipulating CNABs. We have Porter, which is an opinionated CNAB tool. What Porter allows you to do is build applications that require multiple toolchains using mixins. So for example, you could create something that uses an Azure database, but it deploys a compose file somewhere as well, so that uses that database. And finally, there's what my team is working on, which is Docker app, and that's specifically a packaging system for compose-based applications. There are also a bunch of libraries that have come up. So we have the Go library, which we all use. There's also a Rust library, because that's fashionable. Gareth Rushgrove, one of my old colleagues, has written a Python library. And our team built CNAB-to-oci, which I'll discuss just now, which is basically a tool to push CNABs to OCI registries. I met somebody at DockerCon, actually, who works at Intel, who also wrote one for Node.js. So I know there's even more than this that exists already. So when we were developing CNAB-to-oci, we asked, what infrastructure can we reuse? And it's primarily because we're lazy. We just don't want to build things from scratch. We also noticed that the OCI index is designed to handle a list of OCI artifacts. And we thought about this a bit, and we said, well, CNAB has this invocation image and a list of images, so this feels like a good match. The problem with the OCI index is that it does not have a top-level type. So we need to duck type this to make it work. But the overriding design idea behind CNAB-to-oci has been, let's reuse existing OCI registries and not require modifications because it's just too difficult. So this is a bit of registry 101, but basically how it works is that on the right-hand side, we have our blobs. These are just binary bits of data that you push up to the registry. Everything inside the registry is content addressed, which means that when you store it, the registry sends you back an address. You can then combine those blobs up into things and reference them using what are called manifests. So for example, for layers, you could just have a list of layers, which is a list of addresses, and you store those manifests again as a blob, which you can reference from the next item. So it's kind of like this chaining process. So this is what we basically did for CNABs, is we store the bundle definition as a blob. We then store the invocation image, and then the 1 to or 0 to n images that are required by the application. That's all then stored inside what's called an OCI index, which is basically just a list of manifests. I left out one step. We actually support multi-arch, which means that you can have the OCI index. The root one is referencing lists of indexes themselves, because originally the OCI index was developed for multi-arch. So the idea of you can have a Python image that works on Windows, Linux, ARM, AMD, etc. So once again, why we did this? Because it works with existing container registries. This is a good thing. All the images are stored in the same repository, which means that it drastically simplifies the security in RBAC. Because if everything's in the same place, you're guaranteed to get everything that you need for the application back. We also have that because the digests are fixed, it's reproducible. So it's more secure. So with that, I think it's time to show you the real power of CNAB. So we're going to deploy a more complicated application, which is something you would normally require multiple tools to do. So in this case, I'm going to be deploying OpenFast on my machine and installing a Lambda in one step. So this one I also wrote by hand, so this just gives you an idea that this is actually not that hard to do, although people will be building tooling to make it easier. So here's my directory for this one. Once again, I have my makefile to cheat for the commands. I have a bundle.json. I have two tools. I have Docker app and CNAB-to-oci. I have my invocation image folder and a pull.json we'll get to just now. So let's start with the bundle.json. So once again, we've got the same schema version, and the top part's all the same. The invocation image is different because we need a different image to install this application. It's a different application. I then have an image map, and this lists all the images that are required for my application. So I have OpenFast images and things that OpenFast needs. I then have this Python 3 Alpine image, which is used for my Lambda. I then have credentials. So I have a username and a password, which will be mounted into my invocation container at runtime, I have 2 parameters. I have something to set the OpenFast gateway that I use inside my other script. And I have an image map, which is just a variable that I'm using to display the image map to show you how that works. All right, so once again, I've got a similar structure for my invocation image. I have a Docker file. I have a functions folder, which contains my Python Lambda. I'll show you that quickly. And a run shell script, because that was the quickest way of making this work. So I'll start with my Docker file. This one's a bit more complicated. So it's, once again, a multi-stage Docker file. If you don't use multi-stage, you should. It's great. The first step downloads all the bits I need for OpenFast. The second step, this from Docker, that's just referencing the Docker image. And then what I do for the run step is I just copy in the things that I need. So the great thing about multi-stage builds is you can build everything in one image and have all your build chain inside that, but then leave it behind by creating a new stage and just having what you need for the runtime. So here I copy the OpenFast source because I need that for what I'm doing. I copy the fast CLI. I copy Docker, it's the Docker CLI tool. I copy my functions folder. And finally, I copy my run.sh script to be the run script that's used inside the CNAB. So I told you I'd show you the Lambda quickly. It's the world's simplest Lambda. It's simply an echo that will, whatever you send it, it sends back. The more interesting thing is my run shell script. So this is more complicated. So this is actually going to be the thing that runs the install. So you'll see at the top here, I get the CNAB action and the installation name. You can ignore the image map part for now. I'll come back to that. I create secrets, so I don't want to just store my username and password as things inside the image. I want to use Docker secrets so that they're securely stored. I then install OpenFast over there at the install OpenFast step. So I go into the correct repo, I do a Docker stack deploy with the name. I then build my OpenFast function with the fast CLI. I then deploy it. Well, I sleep a little bit to make sure it's stable. Then I log in, deploy it, and I write installation done. The uninstall step is just removing all the pieces there. All right, so once again, I can make the invocation image, and it's the same as what the last command was. It's just building that invocation image. I've done it before, so it should be relatively quick. There we go. Except what I'm going to do when I install this time is I'm going to use Docker app. As I told you, this is a specification, and you don't have to use any one tool to exercise it. So Docker app is a CNAB-compliant client, which means that we can install generic CNABs with Docker app, even ones that weren't generated by it. So in this case, I'm going to say Docker app install. I'm going to pass my 2 credentials there. Don't steal my password. And I've given it a name, FAS, and I'm telling it to use the bundle.json, which I showed you earlier. So this is doing the same thing that Duffle did before. It reads the bundle.json, runs the invocation image, and injects everything inside that's needed. You see, it's already created the secrets. It's now installing OpenFast. This takes a moment. There's a bunch of services to spin up. After this, it builds the Lambda function, which is quick because it's just a Docker build with the source code that I gave it on the Python 3 Alpine image. It logs into OpenFast and deploys the function. That's great. So it says it's done. Let's check if that's true. So if I go to localhost 8080, which is the place that this is installed, you'll see that I have OpenFast installed. And even better than that, I already have the echo function installed. So if I had multiple things set up already, I could install all the functions at the same time and just have this atomic moving of the whole application in one go. I can test it from here by clicking the invoke button. And that works. And obviously, if I want to test it from the CLI, I can do that too. So I can just do a curl, and that works. So that's all working. I'm going to uninstall it, just using Docker app again. Because the credentials are not stored in the claim store, I need to repass the credentials each time I do an operation. And this is just going to run that uninstall script that I had inside my run.sh, but inside the invocation image. So there we go, that's uninstalled. So now that I've made this super useful application, which is just an echo function, I want to probably share it with other people. And so how would I do that? Well, that's why we built cnab-to-oci. So what you can do is you can push the CNAB to a registry. And what that does is it pushes not only the information you have inside the bundle.json, but all the images as well into the same repo. And the reason that's interesting is, as I said before, is it's reproducible. You now have everything in one place. It then returns a digest that I can share with other people. So if I want to print out what this looks like now, may have changed the digest. It did. I'm going to download what the bundle.json now looks like from the information that we have inside the registry. So if we look inside this pool.json, you'll see that this is where the image map comes into play. So here we have this map of invocation image, the map of images over here, which has the key, which is the original name, and then we have the new image SHA, so it's referenced by SHA instead of just by name for each of the images. We can then use this when we do the install, because when we install from the registry, so in this case what I'm going to do is I'm going to be installing this application directly from the registry. So I'm not using the bundle.json now, I'm just using a registry reference. You can see I've also set the image map to true, so this time it's going to print out the image map that I've set. And here you see I'm using the reference that I had from before, although I think that, let's see if this one works anyway. So what this does in the background is it downloads the manifest from the registry. I've included that variable which printed out my image map. So here you can see I have everything I need to replace all the instances where I referenced this image with this one, which is the one that I pushed to my own repo. It's exactly the same image. What's changed here is that it's not fetching it from the OpenFast, for example, repo, but from mine. Because I don't control the OpenFast repo, so maybe that image gets pulled or that tag gets changed. I want to have the same thing. And if we run through the steps, it's just done the same thing again. And if we want to test it, we can just run our curl command again. So that's working as expected. Yeah. OK, so what we've done here is we have not only installed an application that's much more complex than you'd normally expect. We installed OpenFast on a Docker endpoint. We then built a function and installed it on that OpenFast server in one step. We also managed to share this to somebody else using a registry that already exists. I didn't have to write anything else. And I think that's a really powerful thing. All right, so now that you've seen a little bit of how CNAB works and what power there is behind that, what's to come? Well, it's still very much a work in progress. We're still iterating on the specification to make sure that it handles every use case. With specifically work to be done on the claim store, things like how do you handle distributed claim stores? How do you share these applications, the management of these applications? There's a security aspect, so how do we sign these applications in a way that makes sense in the multiple environments? Because it's not that easy. For registries, we have an answer. Is it the same for air-gapped environments or for IoT? And finally, the distribution part. What I showed you was cnab-to-oci. It's one approach to how we could share these things by registries. We're also obviously hoping that more people will be writing tools to exercise the CNAB spec. We want as many people as possible to use this because we really want to be able to share these things and leverage what other people have built. This ties into some conversations that are ongoing about outputs. So what we want to be able to do is understand what a CNAB has done, or so it can communicate to another step so that we can have dependencies. So if we have dependencies, you could do things like install a database and then have another CNAB that deploys an application that depends on that. Yeah. So what do we need from you? Well, we need you to get involved. We have, as I said, we have open meetings every second Wednesday at 9 a.m. US Pacific time. We have the spec up on GitHub at Deus Labs CNAB spec. We have Twitter accounts, and there's a website, cnab.to-oci, that has everything you need to know about CNAB if you'd like to find out more. Right, and all the demos, as I said in my presentation, are up on GitHub if you'd like to grab them and play with them yourselves. So, right, thanks everyone. Yeah.
Questions? Hi, Xibia Labs company. So I have a question. Can I use YAML files?
Yes, you can. So the application definition, a CNAB is, wait, what do you mean? YAML files for the bundle.json or for?
For definition.
So for the application, yes, you can. So the invocation image will contain, you can have YAML files. In fact, the one that I showed now does actually have a YAML file because the OpenFaaS, like the deployment thing for the Docker Stack deploy, is a compose YAML file. So it doesn't matter what you use to define your application, it'll work.
No, I mean definition instead of JSON.
Oh, you mean for the bundle definition?
Yeah.
I think Radu has strong opinions about this. He's sitting over there. I think it used to be TOML at some stage, and then it moved to JSON. Yeah.
Okay.
Yeah.
Yeah. Second question is how can I keep my secrets in a secure manner?
So CNAB doesn't handle that problem. In this case, I use Docker secret. You could easily use Kubernetes secrets or whatever else you're using. It completely depends on your application, right? Because if you're deploying to Kubernetes, you could use Kubernetes secrets. But if you're, for example, deploying on IoT where you don't have an orchestrator, you'll probably want to use something different. So it's kind of a lower level problem for us. We don't have a meta solution for that problem. Sorry?
I can use secrets in JSON definition.
Yeah, so it'll be down to the invocation image as into exactly how it does that. But yes, when you're inside the bundle definition, you define what is sensitive and what is not. And then it's up to your installer to decide how to handle that secret information.
Yeah, so how can I share it?
We don't solve the problem at our level. We're a packaging format, so it's up to the underlying runtime to handle the securing the secrets.
Okay, yeah. Thanks.
Yeah.
Yeah, so I'm Simon Ferkel, I work in Chris' team. And actually, the way we pass credentials to the invocation image, I don't know if it's ready yet or it's still in progress, but what we do is we use a similar fashion as how Kubelet inject service credentials. That's using a temp-fs, a temporary file system in memory in the invocation image container, and we just put data in there, so it's not persisted on disk, it's just something volatile. And we also don't persist that in the claim store for obvious security reasons.
Yes, we do the best we can, but it's not. We don't manage the life of the secret afterwards. Sorry, maybe I misunderstood the initial question. Yeah.
We saw the install and uninstall functionality. Do you have something like upgrade, like Helm?
So do we have something like?
Like upgrade functionality, like
yeah.
You already have something installed and now you want to put a new version there.
Yeah, so we have the three required commands, which I didn't show all of them. I only showed install and uninstall, but the third one is upgrade, which is essentially the ability to upgrade the application. That could be changing parameters or credentials, or it could be changing the bundle reference itself. So those are the three required ones. You can also add custom actions. So in Docker app, we have a bunch of custom actions like inspect and render and some other things that are specific to our tool. So remember, this is a specification, so it just aims to facilitate people building tools. It's not, it doesn't do the actual tool building. Yeah.
Hello.
Yeah.
I want to know what happened with those applications that need an external resources to be deployed, like could be an S3 bucket or I don't know, an RDS database. Is there a way to deploy that infrastructure with the application?
Yes, so that's the point of CNAB as such, is that it lets you do that. It doesn't do it for you, but it lets people who are building tools, so Jeremy, who's sitting just next to you, has actually solved that problem in Porter. But so basically what it lets you do, for example, as you saw in my example, I installed OpenFaaS and then I installed a function on top. In the same way, you could deploy a Kubernetes cluster, deploy an RDS database, and then install a Helm chart in one step. So it's designed to solve exactly that problem. At the spec level, once again. So the spec itself doesn't do it. I didn't show the RDS database example because I don't trust the Wi-Fi.
Hello. I see that you use Docker services, but can we use Kubernetes deployment or pods?
So this was just my example because I did a Docker Stack deploy on Swarm. You could do a Docker Stack deploy on Kubernetes. You could do a kubectl apply with your own thing. It can be anything. There's no, it's not constrained at all. So you must think of CNAB as kind of like the MSI of the cloud, or RPM, where it's just a packaging format. It doesn't care what you do underneath.
Okay.
For sharing, you said that there is a registry involved. What about if I don't want to use the registry, and this can be used for the air-gapped environment where I don't have a registry? I have a CNAB bundle, but I don't want to share with an air-gapped environment.
So that's still work in progress. It will probably depend on exactly how we store these in registries to some extent. Either we will have a well-defined tar format, or we will use the OCI image layout. Because for container images, we have the same problem. And so if we use container primitives inside registries to store these, we can just leverage the same solution for that. So it's still a work in progress, but we will have a solution for that.
Wondering how you define dependencies between services. So in the database example, I need the database running first, and then I want to deploy something that relies on that database afterwards. Is that how you were talking about using multiple bundles, or can you do that within one bundle as well?
So there's both streams as such. Inside the bundle, inside the invocation image itself, it's up to you to manage your own dependencies. So in this case, I needed to get my Docker CLI, my fast CLI, and everything else. There is work being done, particularly by the people working on Porter, who are more interested in how do we link CNABs together. So what is the output of this one, and what can be then consumed by another CNAB? So this one provides an RDS database, this one deploys a Helm chart, and we can link those two together. Yeah, so it's 2 levels. Yeah, that's it. All right, thank you everyone for coming to my talk. I hope you enjoyed it.